All right, welcome back. We are discussing Chapter 2, Lesson 4, Biconditional Statements and Definitions. So here's our warm-up. What you need to do is write a conditional statement from each of the following. Remember, a conditional statement is something that is P to Q. If P, then Q, so you need to identify the hypothesis and the conclusion. So there's 3 different warm-up examples there. I want you to go ahead and pause your device, work those out, and when you get done, press play and we'll go over them together. All right, see you in a bit. All right, welcome back. So we're going to write a conditional statement for each of the following. The first one says the intersection of 2 lines is a point. So this is like one of those tricky ones that we were doing in last section. The intersection of 2 lines is a point. So we have 2 lines intersecting, and then we have this point information. So what I would say is that these 2 lines intersecting, that would be my P, and then the point would be my Q. So how we would say that is if 2 lines intersect, then they intersect in a point. Okay, that would be the conditional for that one. The next one says an odd number is 1 more than a multiple of 2. So for this one, we have an odd number, right? And then the second piece would be 1 more than a multiple of 2. So what are we talking about? We're talking about a number. So what we would say is if a number is odd, then it, or is a number, it is referring to a number, then a number, or I'll say it, is 1 more than a multiple of 2. Okay, so if a number is odd, then it is 1 more than a multiple of 2. So if you think about that, multiples of 2, 2, 4, 6, 8, 10, 12, 14, and 1 more than a multiple of 2. 1 more than 2 would be 3, 1 more than 4 would be 5, 1 more than 6 would be 7, 1 more than 8 would be 9, 1 more than 10 would be 11, 1 more than 12 would be 13, 1 more than 14 would be 15. And when you get up into higher mathematics, how they represent the entire, all the even numbers is just by, they call it 2k, but it could be 2x, it could be any variable. It's just basically any number you put by it, whenever you multiply it by 2, then you get an even number. So like if k is 1, 1 times 2 is 2, even. If k is 3, 2 times 3 is 6, which is even. If k is 4, 4 times 2 is 8, 8 is even. So this is how they express all of the even numbers. All even numbers are expressed by that. Whereas all odd numbers, so that's how you express an even number, any even number. Where all of the odd numbers, right, are actually expressed as, just like they say, a multiple of 2, 1 more, which would be plus 1. So 2k is all of the multiples of 2, 1 more would be plus 1. And so that is how they represent all of the odd numbers, is 2k plus 1, or 2x plus 1, or whatever variable you want to use, but it's just basically 2k, that's even. You take an even number, you add 1 to it, you get an odd number. Okay? So, yeah, but anyways, what you were asked to do is just find the conditional. So if a number is odd, then it is 1 more than a multiple of 2. Perfect. If you got that one right, awesome job. If not, then rewrite it, okay? The third one is asking us to write the converse of the conditional and then find its truth value. So this one's a little bit different. Do you remember what converse is? So conditional is P to Q. The converse is actually Q to P, right? And then we have to find its truth value. So the converse, or Q to P, would be, if this is a conditional, if Pedro lives in Chicago, then he lives in Illinois. So this is our P, and this is our Q, because it's telling us that it's a conditional, and the conditional is always P to Q, right? Then we just need to do the converse, which just flip it. So if he lives in Illinois, then he lives in Chicago. So if Pedro lives in Illinois, then he lives in Chicago. So is that true? If he lives in Illinois, then he must live in Chicago? No, Illinois is a state, and there's lots of places to live in that state. So just because he lives in Illinois doesn't mean that he must live in Chicago. It is possible he could, but it doesn't mean that he must. There's a lot of different places he could live if he lives in Illinois. So this is the converse, but the truth value would be false. Okay, perfect. Let's keep going. So what this says is when you combine a conditional statement and its converse, you create a biconditional. Remember, bi means two. A biconditional statement. So when you combine a conditional statement and a converse, you combine a P to Q and a Q to P, then you get a biconditional statement. And that's what we're going to be discussing in this lesson, biconditional statements. Biconditional statements can be written in the form of this. P, if and only if Q. And those are the key words right there. If and only if. So if you're dealing with an if and only if, you know it, automatically you're dealing with a biconditional statement. Okay, so this really needs to be a flashcard. All of this. Flashcard. Okay, you got to know what a biconditional statement is. Okay, so a biconditional statement is a statement that can be written in the form P, if and only if. This means if P then Q, and it also means if Q then P. So this is that conditional piece, and this is the converse piece. Okay, and remember up here it says when you combine a conditional statement and a converse, you create a biconditional. So this means this is the conditional, P to Q, and it also means the converse. So they're both true, Q to P. Okay, so both work. So whenever you see this, if and only if, in front of the if and only if, that is the hypothesis, and back is the conclusion. Okay, so writing these, the biconditional, P, if and only if, those are those key words again. P, if and only if Q, can also be written as P, if and only if, but they just call it IFF for short, Q. Or they use this little symbol like this, which is a double arrow, which really makes sense, right? Because you can have the P going to the Q, like the conditional, or you can have the Q going to the P, like the converse. It goes both ways, frontwards and backwards, okay? So let's go ahead and look at an example. It says, identify the conditionals within a biconditional, bi means two, conditional statement. Write the conditional statement and the converse within the biconditional. So what we're going to do with this first one is we're just going to appreciate it and look at what we need to do. So it says, an angle is obtuse if and only if its measure is greater than 90 and less than 180. So boom, there we have it. If and only if, those are the key words. In front of if and only if, that is our hypothesis. This is our hypothesis. An angle is obtuse. So we're going to write that down there. P, an angle is obtuse. After if and only if is the conclusion. Its measure is greater than 90 and less than 180. So we'd say for here, an angle's measure is greater than 90 and less than 180 degrees. So those are the things, that's the setup, right? Then we're going to write the conditional and the converse. So the conditional, the P to Q, is if an angle is obtuse. If an angle is obtuse, then an angle's measure is greater than 90 and less than 180 degrees. So that's a conditional. If an angle is obtuse, then its measure is greater than 90 and less than 180. This says 180. Make sure you fix it on your paper. So that's a conditional, and then we have to do the converse, which is just the reverse, Q to P. If an angle's measure is greater than 90 degrees and less than 180 degrees, if an angle's measure is greater than 90 and less than 180, then it is obtuse. So boom shakalaka, there you go. Define your terms, write the conditional, write the converse. That's what you're supposed to do. So let's go ahead and look at an example here. So it says write the conditional statement and the converse within the biconditional. So it's giving us this biconditional statement for 1B. It says the solution is neutral. Oh, and there's that double arrow right there, right? So we know that with the double arrow, this is our P and this is our Q. So P, Q, X, Y, this is going to be our P. Just, I don't know why. Let's just make this a P and make that a Q. Okay, cool. So we would say a solution is neutral, and then for our conclusion, we would say its, which is a solution's pH is 7. So a solution pH is 7. Oh, that's not a 7, that's a 7. Okay. So first thing we're going to do is write the conditional statement, P to Q. So we're just going to say if a solution is neutral, then its solution pH is 7. So if a solution is neutral, comma, then its pH is 7. So there's our conditional. Then we do the converse. If a solution's pH is 7, then it is neutral. And that's really all they're asking us to do for those. So now it's your turn to check it out. I want you to practice 1A and 1B. Here's my friend the pause dragon, remembering you to pause. But first, remember, oh, let's change these to P and R first. Make this P, make this Q, I'm sorry. This is P and Q. So follow this example, define your P, define your Q, then write the conditional P to Q, and then write the converse Q to P. Okay, so for those two examples, when you get done, press play. Oh, press pause first. When you get done, press play, and then we'll go over it. And then if you got it right, awesome. If you didn't, then rewrite what I wrote down. Okay, see you in a bit. All right, we're back. Let's see how we did. It says an angle is acute if and only if, IFF, its measure is greater than 0 and less than 90 degrees. So this is our key words right here, if and only if, IFF, which lets us know that this is our P and this is our Q. So an angle is acute, that's our P. An angle is acute. And then our Q, its measure is greater than 0 and less than 90. So we'd say an angle's measure is greater than 0 degrees and less than 90 degrees. Okay, now we have to write the conditional. If an angle is acute, if an angle is acute, then its measure is greater than 0 degrees and less than 90 degrees. Okay? And then the converse, which would be Q to P. If an angle's measure is greater than 0 degrees and less than 90 degrees, then it is acute. So if you defined your terms, right, your P and your Q, and then you got the conditional and the converse correct, great job. Let's see how you did on example 1B. So it says Cho is a member if and only if he has paid the $5 in dues. So where's our keywords? Right here, if and only if. This is a lovely biconditional statement, which means that this is our P and this is our Q. So Cho is a member. That is our P. Cho is a member. Our Q, he has paid the $5 dues, which means Cho has paid the $5 dues. Awesome. Let's go ahead and write that conditional statement. So if Cho is a member, then he has paid the $5 dues. That's a really terrible money sign. There we go. A little better. Slightly. Not great. Okay, that's the conditional. If you got that right, awesome. Let's go ahead and talk about the converse. If, so we start with the Q. If Cho has paid the $5 dues, then he is a member. And there you have it. Boom shakalaka. If you got that right, awesome job. If not, then rewrite. And I will see you for example 2 in just a little bit. All right, goodbye.